So I had to restart some of the recording, but here am I. Here I am. Here I am. Okay. So based on the information I collected, the network topology diagram looks like this. What we got here is DHCP client connected to switch 1 behind VTEP 1 and 2 in VPC port channel 200. And the source IP, there's no source IP obviously, but the VLAN is 1900, and the DHCP server is connected to switch 2 behind VTEP 3 and VTEP 4 in behind VPC port channel 200, and the DHCP server is in VLAN 1900. The underlay was OSPF, overlay was IBGP, and VRF is 10 and 8. Now, I have this basic information. Based on this, I decided to start troubleshooting. But whenever we go and troubleshoot something, we don't go and run some fancy commands and directly start debugging, right? We first start with making sure the basic information which is required is there or not. So I went ahead and ran a command show run DHCP, and I saw that, as you can see, there is some information is missing, right? So I can see the option 82 was not enabled. In the left you can see, and then unique loopback IP address was not configured. So that was the first problem I saw when I was troubleshooting with them. So we went ahead and configured their enabled option 82 and configured unique loopback IP address. And I asked them, hey, can you please go and check? And they said, no, it's not working. So now I know that I have my basic configuration in place. I wanted to know what I need to do from here, right? So I will use a command like ETH analyzer and run that command on all the VTEP 1, 2, 3, 4 and verify if the DHCP packet are flowing or not. Now, a quick information about ETH analyzer. This tool will show you the packets going to the CPU or go of the 9K or the control plane packets, right? So what we can see that in this case, the DHCP discover packet was reaching to DHCP VTEP 2. Then this packet then went to over the VXLAN fabric to VTEP 4. The DHCP discover packet is now go to server sent with DHCP offer, but this offer did not come back to VTEP 1 or VTEP 2. So that means the DHCP offer was getting lost. And you can see the destination IP for the offer was 10.30.30.2. So I decided, okay, let's check if VTEP 3 and 4 knows how to go to 10.30.30.2 in tenant VRFA. So I went to VTEP 3 and I ran a command show IP route 10.30.32 VRF tenant A, and I see that there was no route. And I think the reason was the unique loopback IP address which we created, we did not redistribute that prefix into VXLAN. So to do that, I created a tag 1234 to loopback 2 IP address, and then created a route map matching that tag 12345, and then I went into router BGP under address family IPv4 unicast and said redistribute direct route map and the name of the route map. And after I do that, the prefix got redistributed into VXLAN, and I went to VTEP 3 and do show IP route 10.30.32 VRF tenant A, and I can see that this packet is now reachable via this IP 10.30.32 is now reachable via 172.16.0.200. So now I said, now we have the route back. Let's go and check. Customer said, you know what? There are some clients which are getting IP addresses, but some clients are still not getting IP addresses. So I said, okay, let's go and check the DHCP packet flow again. Here what we see, the DHCP discover message is received by VTEP 1. The DHCP discover message goes over VXLAN fabric and reaches to VTEP 3. Now VTEP 3 sends a DHCP offer. The offer comes to VTEP 3. The offer was going to 10.30.30.1, which is the VTEP 1 IP address, but it is landing on VTEP 2, which is 10.30.30.2. So VTEP 1 IP is 10.30.31, VTEP 2 IP was 10.30.32, and the offer which was going to 10.30.31 was actually landing on VTEP 2 instead of VTEP 1. And that's why VTEP 2 is going to say, hey, I did not send a DHCP discover message, so I'm not going to do anything with it. I'm going to drop it. Right? So to do that, there are different ways to fix it. But the method I used was, I'll talk about it in short, but just run this command: show BGP L2 VPN EVPN 10.30.30.1 on VTEP 3. You see that this IP address is learned from 172.16.0.200, which is the secondary loopback IP address on VTEP 1 and VTEP 2, which means the packet going to 10.30.31 can land on VTEP 1 or VTEP 2 because that IP address belongs to both the VTEPs, right? But we don't want in DHCP, the device who sent the DHCP discover want to see the DHCP offer. Other devices, if they are not going to forward the packet. So we can change this behavior by using advertise PEEP and virtual RMAC under NV1. So you go under interface NV1 and say advertise virtual RMAC, and then you go under router BGP and under address family L2 VPN EVPN and say advertise PEEP. So what these two command does, so advertise PEEP command is going to send the redistributed routes like the one we did. Those are the type 5 routes. Those will be sent with a primary IP address, and the HMM learn route which will be type 2 routes. Those will be sent as with the secondary IP address. Virtual RMAC is used with the type 2 routes, which is the type 2 routes, which is the like HMM routes or stuff like that, and the system MAC is used with the primary IP. So that for that we need virtual RMAC command. So these two commands works together. And if you configure this and then you go to VTEP 3 and if you say show BGP L2 VPN EVPN 10.30.30.1, you will see that this particular IP now is reachable by 172.16.0.144, which is the primary IP address on VTEP 1. Now, after I made this change, I went and asked my customer, hey, is this working for you now? And they said, went back and checked and everything is working. So I wanted to show them, hey, now let's check how our DHCP packet flow look like. So what we can see here is DHCP discover message comes on VTEP 1. This DHCP discover message goes over VXLAN fabric. It reaches VTEP 3. VTEP 3 gets the DHCP offer from the server. It sends back to 10.30.31, which is VTEP 1. Packet comes to the right VTEP. Right VTEP says, okay, I'll forward it back to the DHCP client. DHCP client gets the offer, now send the DHCP request. The DHCP request comes and goes to VTEP 4, which is okay because VTEP 4 is just going to forward it to 10.180.101 to the server. The packet goes to server sends DHCP acknowledgement, and the acknowledgement comes back to the same VTEP who sent the DHCP request. And that's how the DHCP flow is completing. Now, if any of the configuration on the DHCP server is incorrect, DHCP server will send negative acknowledgement. And if you get the negative acknowledgement, there are a couple of things you might want to go back and check on the server or ask your server team. And for that, I have one more slide which shows you what are the minimum configurations that are required when we configure Windows or DHCP server for VXLAN based network, right? So this example which I'm discussing here is for Windows 2016 server. Now you can see here that first thing you do is create new scope for the IP address range with the unique IP address or the gateway IP address, the one which we configured first. And then what you do, mark all the IP addresses unavailable in that subnet. So when you mark all the IP addresses unavailable, an exception happen on the DHCP server. So when the exception happen on the DHCP server is now going to go and look for a super scope. So for that, you define a super scope. Now under that super scope, you define all the subnets you want to assign the IP addresses from. Now when the DHCP server gets a DHCP discover message, it has option 82 inside it, which has the information about L2 VNI, VRF, and things like that. Now the DHCP server is going to check that information and match that information against the policy which we are creating. So we have to create a scope policy, and in that scope policy, you're going to embed information like L2VNI information, VLAN information, subnet information, VRF information, and based on that, a proper subnet is selected to assign the IP address. And any of this configuration is not done properly, server may send negative acknowledgement. So with that said, my presentation at Cisco Live was over. It was a 30 minutes presentation, but I do have some hidden slides which I'm going to show you now. Let me